Good morning. Today I will discuss about spectrum. What is the benefit of spectrum and waveform? And I will tell you about some basic operations about this vibration, about vibration analyzer. You can see here, this is a vibration analyzer, and I will tell you some basic steps how to operate it. And I will explain you about how to select different options. Now here you can see, here there is a fan. It has got 4 blades. It has got 4 blades, 1, 2, 3, 4, and this is a plate. The blades can touch this cover. If you will press it, it will touch more. I will use this one to press it, then it will touch it more, with more pressure. So let us start, and you will see the spectrum for this one, and we will note down the RPM also. This is a sensor, accelerometer, and when there is a vibration in this fan machine, there is a charge produced in this accelerometer, and that charge is converted into voltage, and then from that voltage we can get here vibration in acceleration and velocity and displacement. So let us start this fan, and then we will see the spectrum and waveform. Okay. You can see here that this fan blades are touching the cover. This is a cover. This one is a cover. Now see, it is not touching now, but now it is touching. So this is a cover, and now we will take the spectrum. Okay, you can see here, downside is vibration analyzer. This is on off button. I will press this button. Now it is on, and this is manual analyze. I will press this one. Now here you can see that F maximum is the frequency range, and there are lines, and then there is average. These are different options here. Now again I go back side. This is manual analyze. Now you can, when you press this one, you can select spectrum, or you can select waveform, and there are other options also. Now I press this one. You can see here, now it is spectrum. But if I want to select waveform, then I will press this one. Now it is waveform. But now it is spectrum. And this button is called home. If you press this one, then you can select display units. You can change from here metric system or English system. Now it is metric system. Here you can press this one. You can select frequency hertz or frequency cycle per minute. Hertz means cycle per second. Okay. Now here you can have different options: displacement, peak to peak, root mean square, whatever you want. And again here you can select velocity, peak to peak, root mean square or average. In the same way, here also you can select acceleration, peak or peak to peak, root mean square, like that. Okay. Now here is menu analyze. If you press this one, you can change the sensor, change sensor type. You want velocity, now it is velocity. You want acceleration, accelerometer or acceleration, now it is accelerometer. Now you press this one, this is velocity. Now it is displacement. Okay, now I will take the spectrum. Okay. Okay, I will stop this one machine and I will tell you about spectrum. Now this is a spectrum. A spectrum is a graph between frequency, this is frequency and this is amplitude. This amplitude can be velocity, or this amplitude can be acceleration, or it can be displacement. Now this one is the amplitude is now in microns. Micron is a unit of displacement in metric system, and 1 micron is equal to 0.001 millimeter. 0.001 millimeter. And you can see here, this is cycle per minute, and here you can see it is telling you here amplitude also. On this side it will tell you amplitude and frequency also. Now let me see what are the different frequencies and their amplitude. I will have to move this cursor to the frequency to see. Okay, so this is 1721. The frequency is 1721, and 3.3 is amplitude. So frequency is 1721 cycle per minute, and RPM is also 1721, and amplitude is 3.32 micron. And you know 1 micron is equal to 0.001 millimeter, and this is a unit of displacement. Okay, so this is the reading for frequency number 1. Okay, and since RPM and frequency are same, it means that there is unbalance in this fan. And how much is the unbalance? That is 3.32 microns. 3.32 microns is telling me how much is the unbalance. When the frequency is same as RPM, it means that the machine has got unbalance. And unbalance, as you know, means that there is a heavy side on the rotor, and due to heavy side there will be a centrifugal force when the rotor will run, it will pull the rotor and there will be more friction and stress inside the bearing, and the vibration will increase and the machine will have short life. So unbalance is the most common problem in the machinery, but it is very easy to diagnose. Just check the frequency, and if the frequency is same as RPM, it means that the problem is unbalanced, and the amplitude at frequency equal to RPM will tell you how much is the unbalance. So this amplitude is telling how much is unbalance, and frequency is telling you that the problem is unbalance. So amplitude is telling you how much is unbalanced. What is the amplitude here? 3.32, and this frequency, which is 1721 cycle per minute, and this is equal to RPM, which is also 1721, is telling that machine is telling that machine is unbalanced. Okay, so what is spectrum? Spectrum is a graph between frequency and amplitude. And what is amplitude? Amplitude is amount of vibration. Amplitude is amount of vibration. So it means that spectrum tells you about amount of vibration or amplitude, and it also tells you about frequency. Frequency tells you about fault in the machine. But for finding the fault in the machine, you should also know the RPM of the machine, and you should know what are the parts inside the machine and what frequency they will generate. So you have to calculate the frequency of each part inside the machine, which it will generate in case of fault. So spectrum is a very useful graph or figure which tells you about both fault in the machine and both about amount of fault or condition of machine. So in spectrum, the amplitude is telling you amount of vibration, and it is also telling you the condition of the machine, or in other words, it is telling you the severity of vibration. Now in this case, when the frequency is equal to RPM, it is telling you that the problem is unbalanced, and the amplitude at this frequency, which is 1721, is telling you how much is the unbalance. So amplitude at this frequency is telling you about amount of unbalance. Now let us see what are the other frequency here and what they are telling you. Okay, let me make this bigger so you can see here what was the frequency here and what was the amplitude here. You can see here that on x-axis it is cycle per minute, it is frequency, and on y-axis it is microns, which is displacement in metric system. And it is also telling you about here frequency and amplitude. You can see here it is telling you about frequency and amplitude. Okay, now let us go to other frequencies and see what are the other frequencies and what are they telling you. Okay, okay, now you can see here that there are 4 blades in this fan, and the RPM is 1721. So what will be the frequency which will be generated by these 4 blades? We will multiply RPM by number of blades, and it is equal to 6884 cycle per minute. Okay, now let us see here the frequency which we see in the meter is 6900 6905 cycle per minute is the frequency in this meter in spectrum, and amplitude is how much? And amplitude is 0.93 microns. Okay, so you can, I will make it. Okay, so you can see here that I will make it. You can see here that amplitude is 0.93 microns and frequency is 6905 cycle per minute, and it is equal to blade pass frequency. Blade pass frequency is RPM multiplied by 4, which is 6884. So almost equal to blade pass frequency. Okay, you can see here that RPM is 1721 and the number of blades are 4. There are 4 blades, and 1721 multiplied by 4 is 6884 cycle per minute, and this frequency if I will see in the meter, it will tell me that the blades are touching the cover. Now in the meter, the frequency which I see is 6905 cycle per minute, which is almost same as 6884 cycle per minute. Now this frequency 6905 cycle per minute is telling me that the blades are touching the cover plate, and the amplitude at this frequency is 0.3 microns. So how I can say that this frequency is telling me that the blades are touching the cover plate? Now we see here in this machine that the RPM is 1721 and the number of blades for fan are 4. So in one revolution these blades will touch 4 times. Now how much are the revolutions in 1 minute? 1721. So how many times these blades will touch? 1721, which is RPM, multiplied by number of blades, which are 4. The answer is 688. The answer is what is the answer? 6905 cycle per minute. 6905 cycle per minute is the frequency in spectrum in our vibration analyzer, which is almost same as 6884. So when I multiply 1721 by 4, the frequency is coming 6884, and which is almost same as 6905 cycle per minute frequency, which I can see in the vibration analyzer. So I can say that the problem is that the blades are touching the cover plate. Now the amplitude at this frequency 6904 is telling me with how much pressure the blades are touching the cover plate. With how much pressure the blades are touching the cover plate. Okay, so this was about okay, I think you can see it now clearly. Again I will repeat now that in order to find out what is the problem in the machine, you have to check the frequency in the spectrum. Okay, and also you should know the RPM. You should know the RPM of the machine, and you should know what is inside the machine. Now in this case there is a fan, it has got 4 blades. So I can calculate the frequency, which will tell me in case the blades are touching the cover plate, and I will say this frequency as blade pass frequency or blade fault frequency. Now in this case RPM 1721 multiplied by 4 blades is equal to 6884 cycle per minute. Now as you know that in one revolution the blades will touch 4 times because they are 4 blades. So in 1 minute how many RPMs are, how many revolutions are? 1721. So how many times the blade will touch in 1 minute? 1721 multiplied by 4 is equal to 6884 cycle per minute. So if I will see this frequency 6884 cycle per minute in the vibration analyzer, it will tell me that the blades are touching the cover plate. Now in the vibration analyzer, the frequency which I see is 6905 cycle per minute, and it is almost same as 6884. So it means that the problem is that blades are touching the cover plate. So now you can understand that in order to know the fault in the machinery, you will have to see the frequency in the spectrum, and then you will calculate the frequency also. For example, you want to find out if the blades are touching the cover plate, maybe the blades are touching the cover plate, then you should know that there are 4 number of blades and the RPM is 1721, and multiplying these two you will get the frequency 6884 cycle per minute. So this frequency, if you will see in the spectrum, it will tell you that the problem is blades. The problem is that blades are touching the cover plate, and the amplitude at this frequency, which is 0.93 micron, is telling you how much, with how much pressure the blades are touching the cover plate. Okay, so this was about. Now you can see here in the spectrum again. So what is spectrum? Spectrum is a graph between, this is frequency and this is amplitude. Now amplitude here is microns. Okay, so we will see now another frequency. What this frequency is telling us? Okay, the other frequency is 7188. 7188. Now the other frequency is 7188 cycle per minute, and this frequency is telling me that there may be problem with the motor, because this is the supply frequency, electric supply frequency, which is 60 Hertz, 60 cycle per second. 60 multiplied by 60 is 3600 cycle per minute, and 3600 multiplied by 2 is 7200 cycle per minute. And the amplitude at this frequency is how much? 3.84. So this another frequency is also telling me that maybe there is some problem with the motor. 60 Hertz is the supply frequency, 60 cycle per second, and 60 multiplied by 60 becomes number of cycles in 1 minute, because there are 60 seconds in 1 minute, and 3600 multiplied by 2 is 7200, and in the meter I see the frequency, which is 7188, almost same as 7200 cycle per minute. So this is telling me that there may be a motor problem. Maybe the gap between the rotor and the stator is not uniform. Gap between rotor and stator is not uniform. Okay. So So again I will make it little big so you can see it here. Okay, so okay, now I will do one more experiment to make you clear about amplitude, what is amplitude and what it tells you. Okay, okay, now you can see here that this is a cover plate, this is a cover plate, and these are 4 blades. Now I will push this object, you can see here, I will push this object towards this side. I will push this, I will move this one. Now this is touching. Now this one is touching this one. There is a pressure, so now it will touch more. See, now the pressure with which this cover plate is touching the fan blades are more. Now what we will see is that we will see in the spectrum the frequency which will be equal to RPM multiplied by number of blades, and this will be blade pass frequency, and it will tell us that the problem is that blades are touching the cover plate same as before, but now in this case the amplitude will be more. Why it will be more? Because the blades are touching with more pressure, because I have pushed this one to this side, so there is more pressure. So I will stop this one and I will see what is the frequency at blade pass frequency. What is the frequency in the spectrum, and what is the amplitude also. So I will see it. Okay, I will move this one. Okay, so this is the one which tells me about how much is the unbalance, because this frequency is equal to RPM. RPM is 1721. Okay, let's go forward. Okay, you can see here that before the blade pass frequency was 6884, the RPM was 1721, and you can see here that the amplitude was 0.93 microns. Okay, now we will see what is the amplitude at blade pass frequency. So okay, so I will write here. So what is the 6864? 6864. So okay, now you can see here that after I push the cover plate and the pressure is more with the blades, the amplitude has increased. How much the amplitude is now? The amplitude is now 1.34 microns when blades are touching with more pressure at blade pass frequency, which is 6864 cycle per minute. And before, the amplitude was 0.93 microns. At that time I did not push the cover plate, so the pressure between blades and cover plate was not that much. After I pushed the cover plate, what happened is that the pressure was more between the blades and cover plate, and the amplitude increased. The amplitude became 1.34 microns from 0.93 microns. But in both the cases, the amplitude which I have taken is at the frequency which is blade pass frequency. So amplitude I will measure at the frequency which is blade pass frequency. So the amplitude at blade pass frequency is telling me how much the blades are touching the cover plate. If the cover plate will touch with more pressure, the amplitude will increase. Okay. So let me do now third experiment. Now I will increase the pressure more and let us see again. Okay. Now I have pushed the cover plate more. I have pushed this cover plate more. So now it is touching the blades with more pressure. So let us see what is the amplitude now. Okay, I will take the reading again. At the frequency which is Okay. Okay. Okay, you can see here that now the amplitude has become 3.84 microns at frequency, which is equal to blade pass frequency, and now it is 6783, which is blade pass frequency, and the amplitude has increased now. From before it was 1.34, before it was 1.34, and before 1.34, the first time it was how much it was? It was 0.93 microns. This was first time. And this was second time. So you can see here that as the pressure of the cover plate is increased, the amplitude increases. But this amplitude I will always measure at the frequency which is blade pass frequency, and blade pass frequency is RPM multiplied by number of blades, which are 4. And you can see here that the frequency is almost same in all the cases, which is telling me that the problem is that fan blades are touching the cover plate. But the amplitude in second time was more than first time because I increased the pressure of the cover plate. And in the third time, the amplitude was more than the second time because I increased the pressure of the cover plate more, and the amplitude becomes more than second time. So amplitude is telling you how much is the problem, and the frequency tells you what is the problem. And to know the problem, as I have told you, that you should know what is inside the machine, what is the geometry of the machine, is there is a bearing inside, if there is a gear inside, or if there is a belt inside, and what are the frequencies which these parts will generate. These frequencies you have to calculate, and for calculating you should know the RPM of the machine and the geometry of the parts. So once you know the fault frequency of these parts, then you will take the vibration reading with the vibration analyzer, and you will see the spectrum. And in the spectrum, when you will see the frequency, you can find out that this frequency is coming, that this is the frequency, and as you know, all the frequencies which are being generated from different parts, you can find out that so and so part is damaged or so and so part has got fault. That's why the frequency is same of that part. The frequency which you will see in the spectrum is same as you have calculated for that part. So this was about how to find out frequencies and amplitude, and this you can find by spectrum. And then you understand now that what frequency tells you and what amplitude tells you. Amplitude is amount of vibration, and it tells you how much is the fault. How much is the fault, or you can say what is the condition of that part. And the frequency is telling you what is the fault. What is the fault? Which part is faulty? From where this frequency is coming? And the frequency is telling you the fault in the machine. If this frequency is coming from the bearing, then the bearing is damaged. If this frequency is coming from the gear, then gear is damaged. If this frequency is equal to RPM of the machine, it means that the machine is unbalanced. If you see two frequencies, one frequency is equal to RPM and other frequency is double of RPM, it means that the machine is misaligned, or there is a misalignment. Okay, now I will show you the waveform. Okay, so I will run this machine, and you can see here that this is manual analyze. I will press this one and I will select waveform. What is waveform? Waveform is a graph between amplitude and time. Now you can see here, this is a you can see here, this is a waveform. On this side is time and on this side is amplitude microns. So this is the waveform. Waveform is also useful to find the fault in the machinery and to know the condition of the machine, but spectrum is more helpful, but spectrum is more useful. So spectrum is number one to find the fault in the machine and to find the condition of the machine. So spectrum is more useful to find the fault and condition of the machine. Now I will take again manual. Okay, now you can again change it into, now again it is spectrum. Okay, now if you want to change the range, you can change the range also from this. Now the range is 2000. Now I have selected the range 2000. What does it mean? It means that I will see all frequencies which are not more than 1980 cycle per minute. All frequencies which are less than 1980, I can see it. This is frequency range. Now I will again put it in waveform and I will see it. Okay, sorry. Okay, again I will take. So you can see here, this is a waveform. On this side is time in seconds, and on this side is amplitude microns. So this is a waveform. So this is a waveform. Waveform tells you how the amplitude of the machine is changing with respect of time. You can see here that the amplitude increase on, then it go down, then it become minimum, and then it go to the peak level. So this is waveform.